Today we are doing 7.1 adjacent and vertical angles. Our I can statement for today, I can identify vertical and adjacent angles, and I can use what I know about angles to find a missing angle measure. So for our key ideas, adjacent angles are two angles are adjacent angles when they share a common side and have the same vertex. So common side means that they both have the same one of the sides that are exactly the same. So angle 1, which is this one, and angle 2, which is this one, are adjacent because they have the same side. And then it also says same vertex. Vertex is like the corner, that point right there. So they have the same vertex, they share a side, and they're right next to each other. It's not one inside each other, it's next to each other. Vertical angles, two angles are vertical angles when they are opposite angles formed by the intersection of two lines. Vertical angles are congruent angles, meaning they have the same measure. So when you have two lines that crisscross, like these do, the ones that are across from each other are vertical. They don't share a side. They do share that same center point, and they're made with the same two lines. So 1 and 3 are vertical, and then 2 and 4 are also vertical. So in our lesson today, our first type of problem is looking at a figure and then naming adjacent and vertical angles. All right, so let's start. Name a pair of adjacent angles. So I'm just going to pick this first one to be my first one. It doesn't really matter. I could pick any one I want. But I'm going to pick this angle right here. When you name an angle, you write an angle line that looks like that. And then you write the 3 letters in the angle. Now the 3 letters here are A, B, F. I can name it A, B, F, or I can name it F, B, A. B is the vertex, that's the point of the angle, and that has to be our middle letter. So I'm going to do A, B, F. But it doesn't matter as long as B is in the middle. And angle, and then I need to pick a different one. I'm going to pick A, B, C. Ooh, I didn't do a good job tracing, but that's okay. That's this one right here. They're next to each other. Angle A, B, C. They have this common side, A, B, F, and A, B, C. If you have adjacent angles, 2 of those 3 letters need to be the same. That's going to be their common side. All right, now we're going to name vertical angles. So I'm going to erase what I've done. And now I'm going to look at 2 full straight lines. I know I see one full straight line here that has the letters A, B, and D on it. That's one line. Here's another line, has the letters F, B, and C on it. The vertical angles are across from each other. So I'm going to pick these 2 as being vertical. So I have A, B, F again. That's this top one. And then this bottom one is C, B, D. Again, that middle point, the vertex, is our middle letter listed. I could have also said A, B, C, which would be this one, and F, B, D, which would be this one. All right. Go ahead and pause the video and try these on your own. Notice that it says 2 pairs of adjacent and 2 pairs of vertical. Go ahead and try these ones on your own. Okay, let's check our answers. So I need to start by writing here, I'm going to do adjacent first. 2 pairs. Last time we just did 1 pair. All right, let's see. I'm going to do V, W, Z. I just picked that one for my first one. V, W, Z. And then I need another one that matches it, that touches it. So V, W, X. Doesn't have to match it inside. It just needs to touch it. They both have that little side, VW, as a common side. They both have the letter W as a common vertex. So this one is VWX. Okay, now I need another pair of adjacent angles. I'm going to pick the ones that are down here. This one and this one, these two, I'm going to make those adjacent as well. So that would be X, W, Y, and angle Z, W, Y. Okay, that's this one and this one. They both share this side. All right, so those are my adjacent lines. Now I need some verticals. There are only two lines here that are crisscrossing. The verticals are going to be across from each other, like here and here. So for vertical, and again, you could have your letters in a different order. So your letters don't have to match the same order as mine. Angle BWX, that's the one on the top, and angle ZWY. The only common letter they have is W, which is that vertex. Okay, now I need another pair. So I'll go with this one. This one right here. This one right here. These two are vertical. They're across from each other. So angle VWZ and angle XWY. All right, let's take a look at number 2. Now number 1, you should really have the same pairs as I do, but 2, there are 3 lines there. So you might have something that is different than what I have, and that's okay. All right, let's start with adjacent. All right, I'm just going to start right here. P, J, Q. And Q, J, K. It's this one and this one. Angle Q, J, K. J, Q, Q, J, they're both have the same 2 of the 3 letters in common. All right, let's see. I'll pick ones on the bottom now. N, J, M, that's this one here. Angle N, J, M. J needs to be your middle letter on these. That is the central vertex. Then M, J, L would be this one. Okay, J, M, M, J, they have 2 of the 3 letters in common. There are lots of different combinations here, so you might have chosen something different to be your 2 pairs of adjacent angles. All right, and then let's take a look at some vertical ones. All right, so we have extra lines here. So it doesn't mean that they just don't touch. It has to mean that they're made of the same 2 lines. Here's one line. Here's another line. I'm going to choose these 2. They're both touching those lines, made up of those 2 lines and across from each other. So it looks like the ones I have here are Q, J, K, and angle N, J, M. All right, and then let's see another one. Same lines. I'm going to trade. I'm going to look at these. This one here is Q, J, N. That's this part. And then this part is K, J, M. The only letter they should have in common is that central vertex, which is J. And they need to be made with the same lines and across from each other. All right, let's take a look at our next one. Tell whether the angles are adjacent or vertical, then find the value of X. Okay, so here I have an angle that's marked 70 degrees, and here I have an angle marked X. They are vertical because they are across from each other. And vertical angles are congruent. That means vertical angles are equal. So if one vertical angle is 70 degrees, that means the other one's 70 degrees. That one I don't have to do any calculating for, I just have to look at the picture. But B, I'm going to have to do some calculations. These 2 are adjacent, they're next to each other. Now this little right angle here tells me that together they're going to equal 90 degrees. That's how many degrees a right angle has. So I have X plus 4 for this part, plus 31 for this one equals 90. Okay, so now I'm going to solve that equation. We've seen ones like this before. We combine like terms that are on the same side of the equal sign as our first step. So 31 plus 4 is 35. So I have x plus 35 equals 90. To get rid of the addition, we're going to subtract. So I'm going to subtract 35 from both sides. All right, and then 90 minus 35 will give us 55 degrees. Make sure your answers here have the label degrees. All right, our last type of problem is drawing, constructing different angles using a protractor. So we're going to go ahead and use our protractor here, and I'm going to show you the steps that you are going to do this. Now you're going to be doing this on your paper along with me. I recommend after I do one step that you pause the video, you do that step as well, and then you unpause for the next step. It's going to be harder for you to do if you watch the whole thing and then try to do the whole thing on your own. So watch part, pause it, do it, unpause, try the next part. Okay, here we go. Draw a pair of vertical angles with a measure of 40 degrees. So our first step is to use the bottom of this protractor like a ruler to draw a nice straight line. Now, unfortunately, my protractor, I can't really press against it like a ruler, so mine isn't perfectly straight. But yours should be. You can press it to make it nice and straight. This is a line. Lines have arrows on the ends to indicate that it goes on forever in both of those directions. So you're going to do lines, and you're going to make a point in the middle. Okay, so now that we have our line and we picked a central point, we're going to line up to measure 40 degrees. You're going to find the center hole of your protractor. Most protractors have a little hole here that we're going to line up with our point. Some protractors look like mine where there's not a hole, it's just you see two lines intersect and there's a center point there. You're going to take that center point and you're going to line it up with your center point. And then you will see a line, like mine has a line right here, not the part at the bottom, but there's a line on the protractor, or there's a gap in the plastic, and then you can see the edge of the plastic. That line has to line up with where the 0 is. So you're going to line whatever that line is on your protractor up with the line that you drew, and the center point is going to get lined up with the point that you have right there. So line lined up with the line, point lined up with the point. We're going to measure 40 degrees. I'm going to go to the right side. So I'm using the bottom side of the numbers because when I go to the right, the 0 on the right side is at the bottom. So that means if I want to measure 40 degrees, I have to use the bottom set of numbers. Then I need to follow it out to the edge and make a little point. If I wanted to make my angle pointing this way, I could have gone to the left. The top set of numbers has the 0 on that way, and then I would have gone to the 40 here. All right, so you've made your point. If you haven't made the point yet, go ahead and do it right there on the edge by 40. Okay, so now we're going to rotate our protractor. This time we're lining up the bottom edge that we used to draw our first line nice and straight. And now this isn't rotating for me. What's going on? There we go. Okay. You're going to line up so that your edge of your protractor touches the point you drew and the original point. And then you're going to draw, it doesn't have to go all the way up to the dot that you drew. I'm not going to go all the way up, but you do need to extend it in both directions. Again, yours should be nice and straight. Mine, I can't really push against, so unfortunately it's close, but it's not quite perfect. The last thing we're going to do is label our two angles that are 40 degrees. Vertical angles are across from each other, In this chapter, when we do constructions, we do whatever the directions say to do. So here it said a pair, 2 vertical angles. We have to label both of them. All right, go ahead and pause the video and try these 4 problems on your own. All right, let's check our answers. So for number 3, this is on a straight line, and a straight line is worth 180 degrees. So these are adjacent angles. They're next to each other. And then I'm going to write my equation. X plus 85, those are my 2 adjacent angles, equals, and then because they're on a straight line, it's 180 degrees. All right, to get rid of the plus 85, we are going to subtract 85. It is okay in this chapter. If you'd like to use a calculator, you certainly can. We're going to get x equals 95 degrees. Don't forget to label your angle. Let's take a look at 4. 4x and this one that is marked with the angle, right angle mark, those are vertical angles. They're across from each other. They are the same amount of degrees, so I can just write x equals 90 degrees. Number 5, these 2 angles are adjacent. They are next to each other. They are in a right angle, so they're going to equal 90 degrees. So I'm going to write 69 plus 2x minus 1 equals 90. Okay, I'm going to combine my like terms. So I have a 69 and a minus 1. If I want to do a boom boom, make that plus negative 1. 69 plus negative 1 is 68. So I have 2x plus 68 equals 90. Now I do order of operations backwards. I get rid of the addition and subtraction first. Cancel out a plus 68 by subtracting 68. So I have 2x equals 22. And then I am going to divide both sides by 2. And I get x equals 11 degrees. All right, our last one, draw a pair of vertical angles with a measure of 75 degrees. And take my protractor. Well, I'm going to use it to draw a nice straight line. I'm going to move the protractor. I'm going to draw some arrows. I'm going to draw a central point. I'm going to line up my center point here with my point here. 75 degrees. I'm going to make my angle going to the right, so I'm going to use the bottom set of numbers. 75 is halfway in between 70 and 80. Make a point. Rotate. You don't have to draw it all the way out to the top, but you do need to draw in both directions. So going up, going down. Arrows. And then label this one with 75. So this one is also going to be 75 degrees. All right, and our last one, true or false. Go ahead and pause the video and answer each one of these on your own, true or false. Okay, let's check our answer. True or false? Vertical angles are always acute. That one is false. They could be right, they could be obtuse, they could be acute, doesn't matter. Number 2, adjacent angles could be acute. Sure, they can be acute. They don't have to be acute. They could both be right angles and adjacent. Adjacent angles could be obtuse. Yes, that's true too. If you had 2 obtuse angles that were adjacent, it would look something like this. Maybe this and this. Here, this one's an obtuse angle, more than 90 degrees. This is an obtuse angle. They're sharing a side. So yes, absolutely they could. Okay. 4, vertical angles are congruent. Yes, congruent means equal in size, and that's true for all vertical angles. 5, adjacent angles could be congruent. True. If I had two 90-degree angles that were adjacent, they'd look something like this. And they would be congruent. They'd be both worth the same amount of degrees.